All right, guys, welcome. You guys have a test next week. We are going to review page 1, characteristics of exponential logs and composition functions. That's what your test is going to be over. Okay, number 1, it says analyze the following functions for behavior after sketching a graph of the function. Draw and label the asymptote. All right, now let's take a look. Best way to do this, if you will, go to your calculator, okay? Where do you go to graph? You go to your y equal, and we're going to put it in just like you see it, okay? So, parentheses, 1 divided by 3 in parentheses, raised to the x, there, that is in the exponential position, right click, minus 3. Make sure you put minus 3 and not negative 3, okay? And if you would, go ahead and hit graph so you kind of have an idea of what the graph's going to look like. All right. Now, I want you guys to go ahead. It says to make a sketch of the graph. What would you do to learn how to make a sketch of the graph? Well, if you hit second table, you can kind of follow where you are going to make a sketch, okay? Do you guys see where it says negative 3 has all repeated? That's your asymptote. That is the line that you're going to approach but never cross. So the first thing you need to do is you need to find that asymptote. And how do you know what it is? Is where your y is repeating. So where is that y repeating? At negative 3, okay? Make sure you check your scale. Notice it's increasing by 2. So let's draw your asymptote. And if you just draw dashes, that would be great. There you go. That's your asymptote. And your asymptote is y is equal to negative 3. And this is a horizontal asymptote. So it's HA. See if I can make that a little bit bigger. You guys see that better? All right. Next part. Let's go ahead and plot. If you go to your calculator, okay, we're going to go plot. First of all, you know you're going to be approaching negative 3. So if you just kind of go and look, maybe go to your 0. At 0, it is at negative 2. So I'm going to put a point there. Let me see if I can do that in red. That might be better. Okay? Next point up, negative 1 and 0. Next one up, negative 2 and 6. You're just trying to get the shape of the graph. Next one is negative 3 and 24. Okay? And then later on, you'll probably get really, really high. Now, connect your points and make your graph. I'm going to do my best. Okay? When you get to down here toward the asymptote, approach it, but do not cross it. And there you have your graph. Okay? All right. Now, when you take a look at the graph, we're going to answer the following question. First of all, is this a growth or a decay? Well, if I did a linear, do you see how from one point to the next it's going down? This tells me this is going to be a decay. Base it off of your graph. Okay? Another way you can look at it is if you take a look at this B right here. Do you see how it's less than 1? If it's less than 1, it's a decay. If it's greater than 1, it's a growth. It's always based on 100%. What is your rate? Well, your rate is always 1, since this is a decay, minus 1/3, minus R, excuse me, minus R, it's a decay, is equal to 1/3, okay? Now you can always solve for it. What is 1/3 from 1? 1/3 from 1 is R is equal to 2/3. So there's your rate. And if you wanted to, and you wanted to actually solve, you would say minus 1, then divided by negative. So you can just kind of think. What is 1/3 from 1? It is 2/3. So your rate is at 2/3. Okay? Next one. Number domain. Well, let's take a look at our domain. Your domain is, if you look at the graph, Far left to far right. How far to the left did we start? Negative infinity. How far to the right did we start? Yes, excuse me. Positive infinity. So this is negative infinity to positive infinity. Okay. Your range. How low did you start? We started at -3, but we never touched -3. So it's going to be parentheses, -3. How high did this graph go? All the way to infinity. Your end behavior. You have a left, and then you have a right. That left will always be going toward the negative, and the right will always be going toward the positive. Every single time, okay? So this right here will always be, left is always approaching negative, and your right will always be approaching positive. Now let's take a look. Left. This is your left side right here. My left side is heading northwest. As it's heading west, it's heading north. What is north? Positive infinity. Oh, you guys write Y, don't you? Okay. Now look at the one down here. As I'm heading to the left, to the right, I'm heading toward the positive infinity. I'm also heading south, but is there something keeping it from going all the way to south? What is keeping it from going all the way down? Well, that value is -3. Okay? This one actually has a number. It's not always positives and negatives. All right? Your x-intercept, that's where you're crossing 0, okay? So if you look, what you can do is you already have a graph. Do you see this one crossing x-axis? Yeah, where is it crossing the x-axis? Two different ways. You can go to the table, which we are at. You can look. X-intercept. When y is 0, x is at -1. So this is at -1, 0. Now, if it was not a perfect number like this, this is what you're going to have to do. Second calc, you're going to go to value. Okay. Oh, I'm so sorry. I was doing the y-intercept. Go to second calc. Go to where it says 0, 2. Do you see where it's crossing right there? Go to the left of that point. Go to the right of that point. And it tells you 0 is at -1 and 0. Two different ways you can do it. If it's not a perfect number, when I say perfect number, I'm saying if it's not an integer, not a whole number, you're going to have to do the second count, okay? All right, y-intercept, what do you see crossing the y-axis? It's crossing at 0, -2. 0, -2. Here's what you can do. You can go to second table, look for where x is 0. Where x is 0, that's where you're going to cross the y-axis, at -2. Or, if it was not a perfect integer, then you can go to second calc, hit value, your x is always 0, so that gives you your y-intercept. Two different ways you can do it, okay? Get off your phone, Garrett. You don't have one of those watched? You have one of those watched? Okay. All right, asymptote. That's what kids are doing. This is a cell phone. Sorry. All right, asymptote. What line is it you're approaching but never cross? Well, that is at -3. My apologies. I thought it was one of those cell phones. You actually have to take those off now during testing. All right, average rate of change. Now, the average rate of change. Students are missing this because they do not know the formula, okay? So let's take a look. You're going from -2 to 2. So what are you trying to figure out? You're going from -2 to 2. Here's your graph. You want to see what that change is from here to here. That's what you're trying to figure out. Did you guys see that? What kind of change should you get? Should that be a positive number or a negative number? It's going down. What do you think it's going to be? A negative. Here is the formula that kids are missing. You ready? Your M is equal to f of b minus your f of a divided by b minus a. That is a formula that you need to know. You always take the second minus the first. It's kind of like y2 minus y1 divided by x2 minus x1. Okay? All right. Your negative 2 is your x of a. Your 2 is your x of b. There's your a and your b. Everyone got that? Okay? This is how you plug it in. How do you find f of b? Well, you go back to your original equation of above. 1/3. What is my b now? My b is 2. I'm going to plug in 2 where x is. Minus 3. Can you just type that into your calculator? Absolutely. Okay? So let me show you guys how. So on your calculator, you're going to type. Let me see if I can move it over. Here we go. Parentheses, 1 divided by 3 raised to the 2. Right click over. Minus 3. What does that come out to be? Negative 2.88888888. You can just round it to negative 2.89. Okay? Do the same thing for your f of a. 1/3. Now, what is your a now? A negative 2. See the negative 2? Minus 3. So do the same thing for that one. So, parentheses, 1 divided by 3. Raised to the negative 2, right click, minus 3. And that comes out to be 6. Everyone see what f of a and f of b is now? Now that you know that, you can plug it into the formula. What does the formula look like? M equal f of b, negative 2.89, minus your f of a, which is 6, divided by your b. What is your b? 2 minus your a, negative 2. And you can just type all that into your calculator, okay? And if you forget how to do it, remember if you have a division, you got 2 things going on, you can do all this in one step if you just put parentheses around these guys, okay? All right, but you also know that 2 minus negative 2 is the same thing as 2 plus 2, correct? So type it in, so you can go negative 2.89 minus 6 in parentheses, divided by, what is 2 plus 2? 4. And so the rate of change is negative 2.22. And there is your rate of change. I'm sorry I didn't give you guys enough room on that paper. Look, here's a moment for you to write it down. That's the part that students miss the most, is that rate of change. Because we don't practice enough of it. What you need, Reese? This one right here? Right here? Take a moment, copy that down. This is the part where students miss, is this rate of change. Because you don't practice enough of it. You need the formula? Okay, any questions so far? All right, let's go to your second one. Okay, same thing, let's go to your second one. I'm going to go a little faster on the second one. I went a little slow on the first, but I just want to go to the second one, go a little faster, and I'm going to make it a little smaller. Just so we can kind of compare, and then I'll make it bigger for each part, okay? But at first, I'll make it smaller. All right, let's go ahead and graph. Here we go. Clear. 5 times, parentheses, 1.5, raised to the x plus 2. Okay, everyone got that? Oops, I screwed up, didn't I? Right click, plus 2. There we go. Hit graph, kind of get you an idea what the graph looks like. Okay. Let's go ahead and go to second table. Let's scroll down. Oh, see how they keep going up? So let's go up. You guys starting to see where the numbers are repeated? We're getting really, really close. What is it getting close to? To 2. So guess what your asymptote is? At 2. So at 2, I'm going to draw my dashes. That means that is the line I'm approaching but never cross. Okay? So this is at y is equal to 2. There's your asymptote. And this is a horizontal asymptote. Now let's go ahead and plot some points. Starting with, look at your x. You're at -8. You can start there. You can start at -6. It doesn't matter. But this is all your x value. Okay? So at -8, you're at 2.1. There you go. Let's go find some other numbers. How about -3? -3, it's at 3.4. So about right here. Okay? Here's a whole integer, 0, 7. That might be a good number to know. 1 and 9.5. How about 4 and 27? There we go. So, you kind of have an idea what your graph looks like. That's all you got to have is kind of an idea. Okay? Draw your graph, approaching the asymptote, but never crossing it. And there is your graph. Okay? All right. Now, looking at this graph, is that a growth or a decay? This is a growth. Good. Let's find your rate. Here is your rate, right here. See how it's greater than 1? That tells you it's a growth. So this will be 1 plus r is equal to 1.5. So what is r going to be equal to? What is 1.5 from 1? 0.5. So your rate is 0.5. Okay? So 1 plus 0.5 is 1.5. So you kind of do that in your math, in your head. It's always just a 1. All right, your domain. Far left to far right. So that is all real number. Or can I write negative infinity to positive infinity? Okay? Your range. How low are you starting? I'm starting at 2, going all the way to infinity. I never touch 2, and that is the reason why it is a parentheses. You guys see that? Okay. All right. Your in behavior. Let's take a look. Here's your left. It is always going to go toward negative. Here's your right. That one is always going to go toward positive. And then you got to figure out if it's going to go north or south. Okay? Here we go. As you're going toward negative, it's heading towards something. It's heading south. Is there something keeping it from going all the way south? What value is that? 2. And there's your 2. Okay? To the right, I'm heading east. As I'm heading east, I'm heading all the way north. Is there anything stopping it from going north? Nope. So you have your infinity. You guys starting to see that a little bit better? Okay, we've done this quite a bit, just making sure. All right, your x-intercept. Do you see it crossing anywhere along the x-axis at all? Nope. Not applicable. If you leave it blank, I'm going to mark it wrong, because that doesn't tell me that you look at it. You got to let me know that you looked at it and it doesn't cross. Okay? Y-intercept, where is it crossing? At 7. 0 and 7. It's right here. Okay? Or you could do it this way. Second count, go to value, enter 0, 0, 7. You can do it like that as well. All right. Asymptote, where did we say it's approaching but never cross? At 2. All right. I'm going to make this a little bit bigger so you guys can kind of see that. Is that better? Okay. Now let's go into the rate of change. You guys ready? This is the part where students miss. Here's your A, here's your B. Okay? Let's do the f of B first. F of B is equal to 5 times 1.5 raised to the 3 plus 2. You guys see where I'm getting this equation from? Just from right up above. Type that into your calculator, just like you see it. 5 parentheses, 1.5 in parentheses. Raised to the 3, right click, plus 2. And what does that come out with? 18.88. Oh, I'm so sorry. Okay. There's your f of b. Your f of a. Same thing. 1.5, except your a is 0 plus 2. Okay? You can type that in, or you can say, hey, anything to the 0 power is 1. 1 times 5 is 5, plus 2, that gives you 7. So you can do the math in your head, or you can type it in. Okay? So now you got your b and you got your a. Now let's plug it in into the equation to find it. I'm going to come down here so you guys can see. M equals 18.88 minus 7 divided by your b, which is 3, minus your a, which is 0. And you can just type all that into your calculator. Okay? Now let's see what we've got. There's a dot right here. Parentheses. There we go. 18.88 minus 7 in parentheses divided by parentheses 3 minus 0. So you can type it in just like that. Okay? And that comes out to be 3.96. So your rate of change is 3.96. Any question? Not bad? All right, moving on to okay, before I do this part right here, let's go over a few things regarding equations, okay? Formulas. If it just says the word interest, you might want to write this down. If it's just mentioned the word interest, okay? Annually, whatever, it just says interest, simple interest. The formula you're going to use is A is equal to P, 1 plus R raised to the T or X. That is the formula you are going to use if it just says the word interest. If it says compound, it tells you how often, like compound annually, okay? The formula you are going to use is A is equal to P, 1 plus your rate over K, you might see it as an N, same thing, raised to the K times T. If it says compound annually. Now annually means your K is equal to 1, okay? Semi-annually, your K is equal to what? 2. If it says quarterly, it is 4, okay? If it says monthly, 12. Weekly, 52. And then daily, 365. So make sure you know that. That is common knowledge. Everyone got that? Okay? Now, if it says compound, keyword right here, continuously. See the word continuously? That's a radioactive decay. If it says radioactive decay or compound continuously, you would use the P times the E. E is on your calculator, and if you don't know it, it's 2.17 raised to the R times your T. Okay. So those are the 3 formulas that you need to know. Yeah. You need to know which one is for what, because I will not tell you. I'll give you those 3 formulas, they'll be on the board right there, and then it's up to you to know it, which one I'm going to use, okay? Any questions? You guys got those 3, you need to know those. Lindsay, eyes up here, honey. What are you watching? Okay. All right, let's look at number 3. Here we go. On number 3, it says, A $25,000 car depreciates 9% every year. Now, notice it doesn't say anything about the word compound, right? So what formula are you going to use? A equals P, 1 plus R raised to the T. Okay, here we go. How much did the car start off with? $25,000. Depreciate means it's going to go down. So there's your rate. It's going to go down 9% every year. When will it be worth less than $5,000? And there's your Y. It says when, so there's your T. Okay? So, now, you guys will do this using intersection, finding the window. You can do it like that as well, but I'm going to show you another way also. You guys ready to learn this way? This one will give you an answer without doing the window. Okay? Ready? Some of you will probably really like this. All right, here we go. Let me find another sheet of paper. Divide by 25,000. Why you divide by that? Because 25,000 times, right? What's the opposite of multiplying? You divide. See how that cancels out? Okay? Then you can just go 5,000 divided by 25,000 gives you 0.2. And that leaves you with 1 minus 0.09 raised to the T. Everyone got it right there? Now we're going to go back to something that you have already learned. B to the x is equal to y. Remember that right there? You remember writing it in logarithm form. How do you write that as a log? Log base b of y is equal to x. You guys remember that right there? Okay. So, here's your base. So you're going to take log base e of 0.2. This is just a little extra. That's all this is. Okay? Equal 1 minus 0.09 raised to the t. Everyone got that? Hang on just a moment. I think I screwed up. I did. It's not log base e. My fault. I lied. It's log base of 1 minus, what is 1 minus 1.09? 1 minus 0.09 is 0.91 of 0.2. Let's see. Base to the y. Yeah, 0.2 is equal to your t. Did you guys see that right there? Okay. Can I type that into my calculator? So you go alpha window, number 5. What do you put right here? 0.91. Right click, 0.2. Right click. So how long does it take for that car to be less than 5,000? 17 years. Okay. So you could do it this way, or you could do the intersection, okay? The intersection requires you to mess with your window a little bit. So, all right. If you do it the other way, this is what you do. Okay, I'm going to keep going so you guys can have this video. All right. If you do it the window, you're going to type in 5,000 right here. Type the other equation right here. 25,000 parentheses 1 minus 0.09 raised to the x. Okay? You have to go and change your window. 0. Let's make this 25. Scale 5. Now, your minimum can be anything, but your maximum needs to be greater than 25,000, so maybe you put 40,000. Okay? And you hit graph. Fill this out and I'll sign it. All right, now do you see where it crosses right there? If you hit second count, go to intersection, first curve, right click over till you pass that point. There you go, second curve. Notice, in 5,000, it's going to be 17 years. So, 2 different ways you can do it, okay?